Alright, section 2.3, techniques for evaluating limits. So there's a few techniques that I want to cover. Direct substitution, simplification, multiplication by a conjugate, and the squeeze theorem. So direct substitution is by far the easiest. That's just going to involve plugging in whatever number you're approaching to the function that you're trying to evaluate the limit for. And then simplification and multiplication by a conjugate are both algebraic manipulations that basically put your expression in a form where you can directly substitute. And then the last thing we're going to talk about is the squeeze theorem. Okay, so let's talk about what direct substitution means first. So I'm going to scroll ahead here. Okay, so suppose we had the limit as x goes to 4 of 3x minus 7. So 3x minus 7 is a line. Okay, it has a slope of 3 and a y-intercept of negative 7. We could sketch that really roughly here. Okay. It's just a straight line. There's no points of discontinuity here that we need to worry about. And we're just curious, what is the function value, or the limit, at 4? So it's fine to just evaluate this limit by plugging in x equal to 4, but because I know that you're all studying the limit laws on page 70, I will illustrate how to evaluate that using a limit law. Okay, so I am allowed to rewrite the limit statement like this. And now the limit as x goes to 4 of x is just 4. And so we'd have 3 times 4 minus 7 is equal to 12 minus 7, which is 5. And so the limit as x approaches 4 of 3x minus 7 is 5. Okay, there's no breaks in the line here. It's just a straight forward function. So we can either say the limit as x approaches 4 is 5, or the function value at 4 is 5 in this scenario. Okay, so that's direct substitution. It doesn't always work out this nicely though. So if we go on to the next example I have, okay, well here we're asked to find the limit as x approaches 3 of x squared minus 9 over x minus 3. Hopefully you can see that if I were to directly substitute 3, I would end up with 0 divided by 0. So, that's usually division by 0, we say it's undefined. When you have 0 divided by 0, it's something called indeterminate. And so we need to do some manipulations to try to find what's really going on. So one way to simplify is to factor. Okay, so with a problem like this, be on the lookout for factoring and simplifying the expression to allow you to directly substitute. So I'm going to factor the numerator, okay, into x minus 3 times x plus 3, because x squared minus 9 is a difference of 2 squares. And now we see that there's a shared factor in the numerator and denominator of x minus 3. So x minus 3 over x minus 3 is 1. And so we can replace this whole expression with simply x plus 3. And now there's no problem with just plugging in x equal to 3 here. So we do that and we get a limit value of 6. Okay? Next, multiplication by a conjugate. So if simplification doesn't seem to be working and you see some radicals in your expression, multiplication by a conjugate might be something to try. It might be helpful. So here, I notice that in my denominator, I've got 3 minus root x plus 5. If I were to directly substitute into the denominator, hopefully you can see I'd get a 0. And similarly, if I were to directly substitute into the numerator, I also get a 0. So let's try multiplication by a conjugate. So for this one, I'm going to multiply by the conjugate of the denominator. So I'm going to go ahead and multiply by 3 plus the square root of x plus 5 over 3 plus the square root of x plus 5. So if we go ahead and distribute all of that in here, it's quite a bit of algebra. Okay, this is actually very similar to the last homework question from this section. Okay, I would say it's maybe the most algebraically intensive question on the homework for this week. Okay, so if we go ahead and multiply through, we are going to get a 9x times root x plus 5 plus 3x times x plus 5 minus 36 times root x plus 5 minus 12 times x plus 5. And that's all divided by 3 minus root x plus 5 times 3 plus root x plus 5. The reason we chose to multiply by the conjugate is because when we do this multiplication, the middle terms drop out and we eliminate the radical. So we just end up with 9 minus the quantity x plus 5. Okay, so let's clean some things up here. I'm going to gather some like terms in the numerator. So I can't combine anything, but I can at least gather the terms that have a radical, and then I can just sort of group the things with the x plus 5 term. So if I go ahead and do that, I think it might become more clear what we can maybe do. Okay. And notice that the denominator simplifies down into 4 minus x. Okay. So I'm going to use a trick called factoring by grouping. Hopefully you've seen this in a previous algebra class. But if I group the first two terms of the numerator and the last two terms of the numerator, I have a greatest common factor of 9 root x plus 5 that I can pull out of both terms from the first grouping. And then I have a common factor of, 3 times x plus 5 that I can factor out of both terms from the second grouping. So if we go ahead and do that, let me go to the next page here, we are going to get the limit as x goes to 4 of 9 times the square root of x plus 5 times x minus 4 plus 3 times x plus 5 times x minus 4 all over 4 minus x. Okay, so now we notice that we have a common factor of x minus 4. That can be factored out, and so we get the limit as x goes to 4 of x minus 4 times 9 times the square root of x plus 5 plus 3 times x plus 5. And that's all over 4 minus x. Now notice that we've got x minus 4 over 4 minus x. Okay. That equals negative 1. So we can simplify this whole mess into the limit as x goes to 4 of minus the quantity 9 times the square root of x plus 5 plus 3 times x plus 5. Now we can go ahead and use direct substitution. So if we directly substitute 4 into this expression, we wind up with minus the quantity 27 plus 27, and that's minus 54. And that is our limit. So I'm actually going to make a new video just for the squeeze theorem question, so stay tuned.